So first up, I am so pleased to invite Dr. Jimena Laporta from UW-Madison. Welcome, Jimena.
Hi, thank you, Maria. Thank you for the introduction. And I would like to start by thanking the Dairy Innovation Hub for their financial support that allow us to do research and sort of stay ahead of the game and identify problems and also try to bring them solutions, particularly for Wisconsin dairy farmers. So this project is a collaborative effort between myself, a lactation physiologist, Dr. Jennifer Van Oss, who's a welfare specialist, and Dr. Joao Doria, who's a precision agriculture expert here at UW-Madison, and Bethany Dadosen, my grad student, who really took over and executed this project. So if you can play the video, Maria, please. Appreciate that. So this is a 3-week-old calf at the Arlington Dairy unit here in Wisconsin. So even if you have never seen a calf in your life, you will agree with me in that she looked very distressed under severe heat stress in this video. So when I moved to Wisconsin from the University of Florida, where I did heat stress work for almost 5 years, the most common question I got asked was, what are you going to do now with your heat stress work in Wisconsin? So I think there's this general misconception that heat stress is just a short-term and unharmful event here in Wisconsin or in the Midwest in general, and even more in calves because they are not often considered for heat abatement practices on farm. So if you take anything from this presentation today, I really hope this is it. Calves do feel the heat too, even in the Midwest, and these early life experiences that they are exposed to can have long-term effects in their life. So here what we wanted to do, we proposed methods to detect animals under heat stress and ways to protect them against heat stress, specifically in a Wisconsin climate and specifically to dairy calves in a hatch environment outside, which is still widely used across the U.S. For calf raising. If you can advance, there we go. So in this first project, what we did, we conducted 2 projects this past summer in the dairy research in Arlington. So with this first project, we wanted to answer some basic questions. When do calves trigger thermoregulatory responses during a Wisconsin summer? When should we start monitoring them, and how should we start monitoring them? So for 3 months from June to August, what we did, we recorded environmental parameters, including ambient temperature, relative humidity, wind speed, and also animal physiological parameters, including respiration rates, rectal temperature. We did this in more than 60 calves, early in the morning, later in the afternoon for 3 months. So when we were done, we had more than 1,000 data points per parameter within a wide range of ambient temperature and THIs to be able to calculate these correlations and breaking points between these parameters. If you can advance, I'm excited to show you some preliminary data that we have. Maria, there we go. So in the top 2 graphs, we have rectal temperature in pink and respiration rate in green in the y-axis versus ambient temperature and in the x-axis. So what we see here is a very strong correlation between the animal base indicators and the environment. So that's a great thing to find. Now, what we wanted to know was when, at which ambient temperature, the respiration rate and rectal temperature start to increase significantly. So this requires a very complex statistical modeling, but for the take home of this presentation, we found breaking points, this sudden change in rectal temperature when ambient temperature was 21.5 degrees Celsius. And we found for respiration rate a breaking point of 21 degrees Celsius. So this is roughly 70 Fahrenheit. So now we can use, for example, respiration rates of 40 beats per minute and rectal temperatures of 38.5 as benchmarks at which calves start to experience signs of heat stress in a continental climate and start to apply management practices to try and alleviate it. So this takes us to our second project. Maria, if you can advance there. Our second project that we also did this past summer at UW-Madison Dairy in Arlington, with the goal of this project was to answer some different questions. This picture shows the back of the hatch depicting the 3 treatments that differ in the type of ventilation that we offer. So we're trying to cool the calves here in a hatch environment. So we had no ventilation here in the middle hatch in pink. All windows were closed. Natural ventilation here in the bright green by opening the rear windows and the extra window kits at the base of the hatch. And the third treatment, we have active ventilation with solar power fans attached to a tube that will redirect that airflow inside the hatch. So these were controlled by a temperature sensor. So they were on when ambient temperature was equal or greater to 70 Fahrenheit. So you can see a demonstration there inside the hatch. So the calves had a temperature probe attached to the tail, and we measure respiration rate and environmental measurements in and outside the hatch. So I'm excited to show you some preliminary data here as well. Maria, if you can advance. Thank you. So what we see here, we see a significant increase in airspeed inside the hatch as we expected, and this translated into slight reductions in the internal temperature and significant reductions in the respiration rate on both types of ventilation compared with the non-ventilated hatch. In addition, we also see skin temperature significantly reduced in the morning in the heifer calves that had access to the fans inside the hatch. So we're now analyzing the behavior for a 24-hour period in these calves to see how and when they use this technology, depending on the time of the day, on the temperature, and we'll share this information when we have it available. But these initial results are very promising, indicating that improving the hatch ventilation creates a less hostile microenvironment for the calf, and this translates in larger reductions in respiration rates and skin temperatures, which is a really great start for cooling purposes. So this analysis is still ongoing, and there's a lot more to each of these projects that I'm showing here today. So stay tuned for more. Maria, if you can advance to my last slide. Thank you. So the main goal with these 2 projects is to begin to test novel and sustainable technologies to improve calf thermoregulation and provide extra comfort to these calves to raise them more efficiently during Wisconsin summers and in the Midwest in general, and to provide benchmarks at which calves start to experience signs of heat stress to alert us to do something. So this work is really a foundation for future studies that will really try and tailor and optimize the timing and the intensity and the application of these treatments to cool calf in a continental climate. So we also expect to expand our future scope to indoor housing and group housing and begin to document, hopefully, the long-term effects and health benefits of implementing these technologies. And we foresee that with the advent of precision farming and the collaboration with Dr. Doria that we have ongoing, that in a few years we can target individual needs of calves to provide heat stress abatement accordingly. So this is everything for me today. Thank you for listening, and I'm going to pass it along to Dr. Ryan Pralle from UW River Falls.
Thank you for the introduction, Jimena, and thank you to all of you tuning in. I'm really excited to share with you today a collaborative project between myself and Dr. Peter Lammers at the University of Wisconsin-Platteville, where we're going to be investigating how we can leverage automated milking systems, or AMS, to employ targeted saturated fatty acid supplementation strategies to early lactation dairy cows. So on our next slide here, we're going to start with the background behind our project. So first is the challenge of the transition cow, and the one that we're focusing on is the energy challenge. So in the top left-hand corner here, we have a figure where on the y-axis we have energy, and on the x-axis, the horizontal axis, we have day relative to calving. And in the middle of that, you see a vertical line popping up. That is the day a cow calves. So on the left-hand side is the dry period, And on the right-hand side is the early lactation or fresh period of the cow. And the different colored lines indicate different types of energy. So yellow is our energy consumed by the cow. Blue is the energy required by the cow. And the difference between those lines we call the energy balance and is our green line. And you can see that our dry cows, as we move left to right, they are consuming more energy than they need. So they are in positive energy balance with that green line above the x-axis. And I like to call these our fat and happy cows that are getting more energy than they need. But around calving and just after, you can see that we have a decrease in the energy consumed by the cow because she has natural reductions in her voluntary intake. And that's going to lag behind this explosion in energy required by that cow. And that explosion in energy required is because of milk production, which is very nutrient and energy demanding. So our green line suddenly shifts to go below the axis, and we have cows in negative energy balance. And these cows now have to rely on their internal storage of nutrients and energy, their fat tissue and skeletal muscle tissue, mobilizing those to support lactation. This is going to put those cows at greater risk for metabolic disorders like ketosis and fatty liver, which can negatively impact a cow's production, health, and profitability. Fatty acids, and specifically saturated fatty acids, become of interest for these early lactation cows for feeding because they are more energy dense than carbohydrates or proteins. So a cow can get more energy per bite than she could with other feedstuffs. So even though these cows have lower dry matter intake than usual, because fat has more energy per bite, they might have a less negative energy balance because they're intaking more energy. And this could potentially reduce the cow's risk for ketosis and fatty liver. Now, some interesting work out of Adam Locke's group in Michigan State has found in mid-lactation cows that the cows that are higher producing, making more milk, actually get more of the benefit from supplemental dietary saturated fat. And we can see this in our figure in the bottom right-hand corner. And on the x-axis, the horizontal axis, we have preliminary milk yield, so how much milk the cow is making before the study began. And on the y-axis, we have the cow's 3.5% fat-corrected milk yield, which was measured at the end of the study after receiving dietary treatment. And the solid black line is our cows that received no supplemental fat. And the dashed line is our cows that received supplemental C18, which is a saturated fat. And you can see going from left, which is our lower producing cows, to right, our higher producing cows, those lines start to split apart. And we can see that the increase in milk production for supplemental saturated fat was really realized in those higher producing cows, not the lower producing cows. Now, where does AMS come into play? Well, we'll see that on our next slide. So the AMS, like the Lely A5 pictured in the top left, has an interesting component where you can see that the cow standing there being milked also has her head reaching into a stationary, well, into a bucket where a measured amount of feedstuff is being delivered. This measured amount of feedstuff, and we can also alternate the type of feedstuff being fed, allows us the opportunity to targeted feed specific individual cows in a mixed group pen. And by mixed group pen, I mean a pen of cows at a variety of lactation stages, so early lactation versus late lactation, or different levels of production, what we might call a high group cow or a low group cow in a nutritional grouping strategy. So with this technology, our hypothesis is that we can provide a targeted amount of supplemental saturated fat to early lactation cows to improve their productivity and metabolic health by reducing their negative energy balance, with those greater producing cows receiving a larger benefit than the lower producing cows. So how do we design a study to interrogate this question? Well, I have that outlined in the top right. And you can see on the left-hand side of that figure, we start by dividing our cows into lower producing cows and higher producing cows based on their previous lactation milk yields, which at that point of time at calving is our probably best indicator of how much potential milk that cow can have. And within those two groups, we randomly assign cows to receive no supplemental saturated fat, our gray boxes, or to receive supplemental saturated fat for the first 3 weeks or 21 days of lactation. Those are the orange boxes. And during this period of time, we are going to measure cow productivity, cow body weight changes, energy balance, as well as blood metabolites that indicate whether or not a cow might have ketosis or fatty liver. And from all this data, we anticipate a few different outcomes. First, some practical feeding recommendations for supplementing saturated fat to fresh cows, specifically how we can use the AMS to do targeted nutrition and whether targeting this nutrition based on previous lactation production level is beneficial. And our second major outcome is to provide evidence of whether or not supplemental saturated fat improves metabolic health of early lactation cows, something that to date hasn't been intensively investigated. So with that, I'd like to thank all of you for listening to my presentation. I'm eager to hear your questions in the Q&A, and I am now going to pass the mic off to Dr. Kate Creutzinger to discuss her research.
Hi, Ryan. Thank you so much for the introduction. Now that I've heard your research, I think that we need to have a chat about transition cows. But we can do that later. Right now, what I want to do is talk a little bit about a disbudding project that I am working on at River Falls with my colleague, Dr. Sylvia Kehoe. I feel very lucky. I was hired in January, and we applied for this funding in February. And so now it is something that we'll be exploring together in my new appointment. And if we look at this calf in the picture, this is a, oh, Maria, if you could go back a slide. Here we go. If we see this calf in the picture, this is a young Holstein calf who has been cautery disbudded, or chemical disbudded. We can see the paste that's on her horn buds, and pretty clearly it's orange. And so, Maria, if you'll go to the next slide. What we really want to do with this project is to look at the pain associated with disbudding as well as the effectiveness between two brands, as well as looking at different volumes. And one of the reasons that we are so interested in disbudding is because in the current dairy industry and the current climate, we see about 94% of calves who are retained as herd replacements are disbudded. So there's a really large number of animals who are going through a painful procedure. And there are two different types of disbudding that are commonly used. One is a cautery burn, so it's heat and it actually uses heat to burn the horn bud. Or we see chemical or caustic paste disbudding, which causes a chemical burn that then destroys the horn bud. Compared to cautery disbudding, using paste is a relatively fast and easy process. Typically, it just gets scooped out of the jar and then rubbed on a horn bud, wait, and it does its job. And looking at the first photo on the left, it is a sort of quick and dirty comparison that we did between brands. So there are two major brands that are used. The first is Dr. Naylor's and the other is Dr. Larson's. And the recommendation from both brands is to use about a quarter size allotment. This is kind of a vague recommendation. I think that a quarter size amount can vary pretty substantially. And so what we did was we traced sizes of quarters to see how much spread that would require. And from 0.3 all the way up to 0.9 mils, we could keep that volume within the quarter size amount. But if you look at the second photo in the middle, it's really easy to see that on the left side, which is 0.3 mils, it barely covers the surface. But then if you look at 0.9 mils, it becomes very thick. And so what we want to do in this comparison is determine a few things. The first is to determine how much paste is needed to be effective. So we will be disbudding calves with the different volumes and then following them to see if there is any partial or full regrowth of horn buds, because we don't want to do it again. Of course, we don't want to have to go back and re-disbud calves. We will also be looking at the wound size and healing. So if you see that calf on the right, this is a calf that had a lot of paste and it caused quite large wounds on her head. So we will be disbudding or applying the paste and then following calves to see how wide and deep the wounds become, and then detail that healing process over time to see if one heals more quickly than the other, and how we can use an effective amount of paste, but not too much so that it becomes a really large and painful wound for the calf. And then the last thing that we want to look at, which is really important to welfare, is trying to assess the pain related to the different brands as well as the different volumes. We'll do this by measuring pain behaviors and also using pressure algometry to see how much pressure a calf will take before moving away. That being said, one of the challenges with measuring pain behaviors in this study, specifically for paste disbudding, is that calves are generally disbudded during the first few days of life with paste, and so they don't perform those classic pain behaviors that we see in older cows when we do things like pottery disbudding. And so one of the things that we hear frequently is that younger calves don't think that disbudding is as painful because they don't perform those same behaviors, but something that we're hoping to do are determine some novel or clear indicators of pain that for calves who are between 1 to 5 days of age. And I keep talking about what we will be doing because we haven't started this project yet, but we hope to be collecting data in the new year and start enrolling calves on this project. After we collect the data and we are able to see effectiveness, wound size, and pain and put all of those findings together, our overall goal is to provide recommendations to producers in terms of brand as well as the amount of paste that's needed to be effective, but not too much that we're causing unnecessary pain in dairy calves. So I think with that, I will pass it back over to Maria, but we're really looking forward to get started on this study.
Thanks so much, Kate. The Q&A, the chat is on fire for this group. Lots of questions, and we're a little bit early, so you guys are the lucky ones, and you're going to get some extra time for Q&A. So this one is for Jimena. Patrick Beyer from the chat is asking about whether or not solar could be used to keep calves in hutches warm in the winter, maybe like in addition to their jacket or instead of a jacket. And have you thought about looking at that?
It's reading my mind. Yes, absolutely. Yeah, we're gonna try and see if we can do that now that we have the solar panels. I was talking with the person that we acquired the solar panels from, and it might require a little bit more power to blow heat than cool air. So we're going to try and tease that out and test that. But that's a really good question, and I'm looking forward to be able to answer that hopefully soon. Thank you.
Great. And I think this next question is for Ryan. It's from Cassandra Strupp in the chat. Where or how will first lactation heifers fall into this possible application?
That's a great question, Cassandra. So my preliminary thoughts are, because we don't have previous lactation information for those animals, maybe we can utilize genomics to start teasing out cows that are first lactation cows that will be higher or lower producing if we wanted to do a pre-calving assessment of productivity.
Thanks, Ryan. Let's see how we're doing on time. Okay, we still have time for more questions. So this one is probably mostly for Kate and Jimena. Your projects both focus on calf welfare, different aspects, obviously. But what role do you think improvements in this space will make for the lactating life of the animal?
I can take on that, and Kate, if you have any more thoughts. A lot of the research that I'm doing and in other species is showing that early life experiences can really have long-term effects in health and productivity. And obviously, this is not new, and a lot of research has been done in the early 80s and 90s on this in humans. But I do think that improving welfare and those early life experiences in these calves really can improve. It's the problem is that it's complex, and it's hard to really do those experiments and show the long-term effects. And so that's why we don't have a lot of that. We have a handful of studies showing long-term effects, but the research we do with heat stress, even prenatally and postnatally, we see effects 3, 4, 5 years down the road. So I think there's a lot of possibilities here, improving cow comfort, calf comfort and welfare, and providing them with a better environment. It's really going to be beneficial in the long run. It's just difficult to show that, and that's why we don't have that much data. But I don't know if, Katie, you have anything else to add to that.
Yeah, it's definitely a complex problem, and I think maybe Jimena's research will have more impact on specifically lactation and the milk producing capacity. For calves and disbudding, I think that there are multifactorial aspects. So the first is making sure that we aren't subjecting calves to unnecessarily painful procedures when we have other alternatives, just because subjecting them to acute pain is a poor procedure. But ultimately, if we think about the large picture and sort of our calf care practices as a whole, one of the things that we see is as animals have negative experiences or more negative experiences, they're more likely to have negative cognitive biases. And so if we look at the experiences that calves pull from the world and how they put them all together, what we see is they change their assessment of new situations. And this could be new handlers, introduction to the parlor, pen changes. They sort of become less resilient and more fearful as time goes on. So if we can try to reduce the negative practices and increase sort of the positive practices for calves, then ultimately we can see a mindset change in our mature animals, which can change how they react to new things. And dairy cows really experience new things all the time, whether it's new pens, interactions with new animals, introduction to the parlor. So thinking about it on a larger scale rather than just one isolated experience is important.
And if I may add to what Kate just said, stressors are additive. So if you think about all those, what these calves go through in early life, excuse me, if you think of a calf that is going through some pain because of the disbudding and she's under heat stress on top of that, so that really can have an additive effect on stress in general. So have to be cautious as well with that.
Thanks. We do have one more question for Ryan. So with AMS systems, robotic systems, there are a lot more options for supplementation. Do you see a role for multifaceted supplementation programs in a herd to create, let's say, a fresh cow diet when there might not have been the opportunity to have that at like a normal, feed bunk situation?
Absolutely. I think that one of the real opportunities from a nutrition perspective for AMS robotic milking systems is that now we can start personalizing nutrition a little bit more for a cow within a pen. And we can do that either by changing the rate of a concentrated feed stuff to match the cow's needs at that point in her lactation, or to optimize other herd goals like feed efficiency, nitrogen use efficiency, etc. So that's going to be a real opportunity. And also with the opportunity of having multiple different types of concentrated feedstuffs to be fed out within one pen, we can come up with fresh cow rations within a mixed group of cows. So that's one reason why I'm really excited about AMS, is because I think it's going to be a great opportunity for nutritional grouping on smaller scale operations where they can't segment cows or group cows across multiple large pens.
Thanks, Ryan. And so I think that's it for this panel today. I just want to thank the three of you for giving us your time today. And I thought we had a great discussion. And for those of you who are planning to stay on for the duration or maybe pop back in at 12:30, you're going to hear from Ryan and Kate again as part of the new faculty roundtable. And Jimena, welcome to UW-Madison. As she said, she is a transplant from Florida, so we're excited to have her as part of our great state and the talent that we have here.